In this nugget, we're going to see how we can protect our distributed logical routers with the extra service of high availability. And we'll do it together in a hands-on lab. For this hands-on lab, we've logged on to the VMware hands-on lab environment, HOL 1903, fired up Google Chrome to access the vSphere web client, logged on as administrator at vSphere.local, and now we're ready to enable HA for distributed logical router. So let's click the home button and head down to networking and security. On the left-hand side, we'll head over to NSX edges. And for this lab, I'd like to show you the process from the beginning. So I'm going to have us delete the existing logical router. So we'll go ahead and delete that, say yes, and then we will create a new distributed logical router by clicking the green plus and clicking add. We'll choose logical router. We'll call this test HA. And down at the bottom, we have the ability to add a checkmark to enable high availability and the ability to add HA logging. And this is true whether or not we choose a logical router or an edge services gateway. Then we'll click next. We'll need to go ahead and specify the password that is used for direct shell access. VMware1 exclamation point, VMware1 exclamation point. We'll add a checkmark to support secure shell, and then we'll click next. Under configure deployment, we'll click the green plus to add our initial edge appliance. From the drop-down menu, we'll choose management for the cluster, and from the data store, we'll choose the iSCSI data store. And we'll leave the host folder blank and allow it to use the default system managed reservation and click OK. Now what we just defined are the VM properties of the control VM that is there to support the DLR. We do not need to click the plus again to add a secondary instance to support HA. HA will add that second instance for us automatically. Let's click next. When we get to interfaces, we're presented with something very different because we added HA on our initial settings screen. The question is, what will the HA interface configuration be connected to? And when we choose select, we get a list of logical switches or distributed virtual port groups. So for this example, we'll click the Transit Network 01 logical switch and click OK. So just to make sure this is clear, this is a distributed logical router. So we have multiple ESXi hosts, but then we have this router that is shared in common between all of those devices. They all host that router natively, but to be able to support firewall and dynamic routing protocols, we also have the creation of a separate VM that'll be hosted on some other ESXi platform. It is this VM then that we are copying as we create an active and standby situation, and this transit network is the network that's going to be used by those VMs in order to communicate their heartbeat information. So the control VM for our router is going to have an interface that is automatically plugged into the transit network, that VXLAN, in order to communicate the heartbeat information necessary. Down below that, we can configure interfaces of this NSX edge. We can click the green plus there, and this is where we configure internal and uplink interfaces. So for example, we could say that the transit network, we'll type in transit, is in fact an uplink interface that this can use. Click select, choose Transit Network 01. So this is a separate assignment that has nothing to do with the other HA interface configuration. This is to be able to support having an interface association that supports an IP address that is able to be used for routing. So in this case, we'll type in 192.168.5.2 with a prefix length of 29, and then we'll click OK. And then we can click the green plus again. Then to support the app tier network, we'll type in app tier as the name of this next interface. Choose internal for east-west routing, choose select, and we'll choose the app tier logical switch. All right, and then we'll click the green plus to assign an IP address for configure subnets 172.16.10.1 with a prefix length of 24. Then click OK. We'll go ahead and click next. And here on the default gateway page, we're just going to type in a gateway IP address of 192.168.5.1. That's our uplink router. Click next. It's ready to complete, and now we can click finish. It's busy installing this edge device for us, but when it's done, it should already be set up with HA pre-configured. And now that that's been deployed, let's go ahead and open up that new test HA device. We'll head over to the Manage tab and take a look at our configuration. We can see over here on the right-hand side, the HA status is enabled with a 15-second declare dead time. Logging is enabled, logging level of info. We click change in the upper right-hand corner. We can customize that, disable it later if we want to, re-enable it back again, and we see the reference for what logical switch that particular VM is hooked into. We can cancel out of that, And if we scroll down to the bottom, we can actually see the logical router appliances. Here's test HA0 and 1. We see the itemization of what's active and what's standby. They're both administratively up, but you'll notice that there actually are not any buttons to be able to change that admin state here inside the vSphere web client. If we want to delve a little deeper into its properties, then we can head up to it as a virtual machine itself. Let's head up to VMs and templates from the homepage menu, expand out region A1. There's test HA0 and test HA1. Let's select test HA1, the current standby device. We'll click on the thumbnail to log into it. Press spacebar to wake it up. Log in as admin with the password of VMware1 exclamation point, VMware1 exclamation point. If we type in show service high availability, we can see our current configuration as a standby device, the available running nodes, dead time, and the assigned IP addresses on this link, which, unlike with an edge device, we did not have the ability to assign ourselves. It automatically chooses IP addresses out of that APIPA range. Let's leave that tab open and hop back over to the vSphere web client. And as a way to force failover, in this case, let's right-click on test HA0, head up to power, and choose suspend. And say, yes, we are willing to suspend HA0. Then we're going to go to test HA1 immediately and up arrow and show service availability. And it still says it's a standby device, even though I just caused the other device to be put into suspend mode. But remember, if we checked before there were 15 seconds, then the initial device is still considered active by this device. Let's do show service high availability again. This second VM is now the active VM. And down underneath the high availability health check status, we can see that 169.254.1.5 is considered unreachable. You can spacebar and type in exit. Let's close that tab. And let's bring back that VM by right-clicking on it, heading to power, and choosing power on. Will this device become the active node now? No. HA assumes that whatever device is currently active should stay active until there's a need to fail over to the other device. Well, my friend, by going through this hands-on lab together, you've learned the skills necessary to enable HA to protect your control VM for a distributed logical router. This means that your firewall configuration is always going to be upline and available, and that means that your ability to receive dynamic routing protocol information is always upline and available. And I would say that this is kind of a second tier of HA compared to an edge service gateway, because the router itself is on all of our ESXi hosts. This is just that control element that we're providing the extra protection for. But to have all the tools in place to keep your systems up and running and healthy and happy, enabling NSX's high availability is a great solution. I hope this has been informative for you, and I'd like to thank you for viewing.